All right, so today we're going to move on to the next lesson in Unit 1. We're actually going to do what we're going to do today is actually going to cover lessons 8 and 9. So we're going to do both lesson 8 and lesson 9 today. And what lesson 8 and 9 have to do with is this thing called the closed form, also known as the explicit form. It's just simply a different way of expressing, formally expressing a sequence. We, of course, earlier this week talked about the recursive definition, the recursive form of a sequence in lesson 5. And while the recursive form is very useful in certain instances, there are instances where the recursive form will not help. So, for example, if I ask you to find, say, the 100th term of a sequence, and you had to use the recursive form. Well, in order to find the 100th term, you would have to know what the 99th term is. And in order to know the 99th term, you would have to know what the 98th term is. In order to figure out the 98th term, you'd have to know what the 97th term is, so on and so forth. So it would be nice if we had a way where I could just plug into a formula and figure out what the 100th term, what the 500th term is, without having to figure out each term previous to it. So that's the one disadvantage of the recursive form. So that's what we're learning about today. This closed form or explicit form actually allows us to figure out a specific term in a sequence. It essentially allows us to plug into a formula, and I don't have to worry about figuring out what each of the term prior to that is. So I can figure out the 500th term of a sequence without having to figure out the 499th, the 498th, the 497th term, so on and so forth. So this right here, these two things right here and right here, are the formulas that we're going to use for the closed or the explicit form, depending on if it's geometric or whether it's arithmetic. If it is neither, there isn't a shortcut. So we're only going to focus on geometric or arithmetic sequences. So you can see this is a formula that we plug into to figure out the closed or the explicit form. And all we need are two pieces of information. We need to know the starting term, term 0, as we call it, or f of 0. And we need to know if it's geometric, we need to know the common ratio. If it's arithmetic, we need to know the common difference. So to show you how that works, let's look at these examples here. And this is basically what we're going to look at today is determine what type of sequences it is, and then use the formula as in the lesson notes. So let's take a look at number 1. Okay, so number 1. Okay. So for the following sequences, determine whether it is geometric, arithmetic, or neither, and then write the closed or explicit form. So if I look at number 1, I go from 5 to 15 to 45. To me, that looks like a geometric sequence because I am multiplying by 3, right? Because 5 times 3 is 15, 15 times 3 is 45, so on and so forth. So this is a geometric sequence, and my common ratio is 3 because I'm multiplying by 3. So now that I know it's a geometric sequence, I'm going to go back to my notes, and I'm going to write down this formula right here for the closed form of a geometric sequence. So it's going to be f of n equals f of 0 times r to the power of n. And we're going to simply fill in the numbers. We're going to fill in the numbers that we can. So f of 0 is our starting term. Well, what is the starting term for the sequence? The starting term is 5. So f of 0 is 5. And then r, remember, is our common ratio. So what did we say our common ratio was? Is 3. So my closed form is going to be this: 5 times 3 to the power of n. That is what we call the closed form. And what makes this useful is I can plug in any number I want. So if I wanted to find the 10th term, I would plug in 10 for n. So I would figure out 5 times 3 to the power of 10. If I wanted the 200th term, I would plug in 5 times 3 to the power of 200, so on and so forth. So that is how we do closed form. Let's look at number 2. So number 2, we go from 1 to -5 and to -11. It looks like we are going 1 to -5 is going down, and we're going down by 6. 1 minus 6 is -5. -5 minus 6 is -11. So this is an arithmetic sequence, and our common difference is -6 because we're going down by 6. Okay. So now I'm going to go over here, and I'm going to go to the formula for an arithmetic sequence. And I'm going to write that down. So f of n equals f of 0 plus or minus d times n. And I'm going to fill in the numbers. So f of 0 is the starting term, so that is 1. And then we are going to do minus because our common difference is negative. So we're going to choose minus. And we said that our difference was -6. So my closed form, my explicit form, is simply 1 minus 6n. Okay. Let's look at number 3. Okay, so number 3 looks like an arithmetic sequence. Why is it an arithmetic sequence? Because we are going up by 3. We are adding 3 each time. So our common difference is 3. So I'm going to use this formula again for an arithmetic sequence. So f of n equals f of 0 plus or minus dn. Okay. So f of 0, once again, is our starting term. So what's our starting term for number 3? Our starting term is 4. Okay. Now are we going to do plus or minus? Well, our common difference is positive, so we are going to do plus. And what did we say our common difference was? 3. So my closed form is 4 plus 3n. Okay, and just like with the geometric examples, I could plug any number for n. If I wanted the 1000th term, I could plug in 1000 in for n and calculate the answer. Okay. Let's finish out and look at number 4. Okay. So number 4, we go from 12 to 3 to 0.75. That is going to be a geometric sequence. It's going to be geometric because we're dividing by 4. 12 divided by 4 is 3. And 3 divided by 4 is 0.75. So my common ratio is going to be 1/4, 1/4, because we're dividing by 4. Okay, so I'm going to go back just like I did on number 1 and use that formula. So f of 0, or excuse me, I messed up there, f of n equals f of 0 times r to the power of n. And I'm going to plug in the appropriate numbers. So f of 0, once again, is our starting term. So our starting term in this case is 12. And r is our common ratio. And we said our common ratio was 1/4. So 12 times 1/4 to the power of n. 12 times 1/4 to the power of n. And that is how we write sequences in closed or explicit form. So what you're going to want to do is in the future, you want to pay attention. If it says to write it in recursive form, you want to use this stuff that we learned earlier this week. And if it says to write in closed form, like it did in these examples, you want to use this information right here that we're learning today.